What do this suspension bridge, this stanchion and rope, and the gateway arch in Missouri have in common? Beyond appearances, the curvatures they share come from the same family. Have you ever wondered what curves cables form when under the influence of gravity? More specifically, how can we model these curves mathematically? By now, you probably already have some questions in your mind. First of all, what are these curves called? And are they parabolas? And why should we know these curves in the first place? The answer lies in catenaries. They look deceptively similar to parabolas, although the two functions are very different in composition. However, they are related, as the focus of a rolling parabola traces out a catenary. The hyperbolic cosine is one commonly used catenary model. While a parabola is a correlation that contains a squared independent variable to obtain its shape, such as x squared, a catenary curve relies on exponential functions of base e. Hyperbolic trig functions are similar to ordinary trig functions, except they define a unit hyperbola instead of a unit circle. Hyperbolic cosine is also defined algebraically, unlike ordinary cosine. In this equation, a is any number that tells us how high the bottom of the curve is from the x-axis. Think of it like dangling a rope. The a on the outside raises and lowers the bottom of the rope, while that same a under the x vertically stretches the curve to correspond to the lower heights. This animation demonstrates the effect of the a variable. Notice how the two a's in the equation alter the curve together to account for lowering and raising the hanging cable. And now you're thinking, how does our math play into real life? Catenaries are used throughout architecture and engineering, from designing naturally force-resistant bridges and arches to ensuring electric transmission lines do not hang too low. If we were to show how E, Euler's number, is present in everyday life, then the catenary is a perfect example. But most importantly, now your day is better, because you know something that Galileo didn't and most people still don't know.